friends. I am Vijay Kumar S. Biradar, HOD General Science and Engineering at NB Navle Singhgad College of Engineering, Solapur campus with 19 years of experience. Today we are going to discuss the subject Control System 2 for T Electrical Engineering, and the topic that we are going to discuss today in this lecture is state space to transfer function conversion. Let us convert the state model to a transfer function model. And the state model for a given system is represented by equation 1 and equation 2 as x dot is equal to ax of t plus b into u of t, which is the first equation known as state equation, and second equation, which is known as output equation, represented as y of t is equal to c into x of t plus d into u of t. Here the matrices A, B, C and D are all constants. Therefore, this given system represents a linear time invariant system. So as we want to obtain the transfer function, we'll use the Laplace transform technique for obtaining the transfer function. So taking Laplace transform of equation 1 and equation 2 and also considering the initial conditions to 0. That means all the state variables are having the 0 values at time t is equal to 0. Therefore, taking Laplace transformation of equation 1, we'll obtain the equation s into x of s is equal to a into x of s plus b into u of s. Let us represent this equation as equation 3. Then the Laplace transformation of equation 2 is y of s is equal to c into x of s plus d into u of s, representing this as equation number 4. So we'll simplify these two equations and we'll get the ratio of Laplace transform of output to the Laplace transform of input. Here all x represents the state variables, u represents the input variable and y represents the output variable. So the Laplace transformation of output to the Laplace transformation of input with all initial conditions to be 0. This is the definition of transfer function. So we are going to obtain the transfer function as the ratio of y of s to the u of s. So from equation 3, we'll obtain the value of x of s. As we want to eliminate the x of s in equation number 4 and represent this y of s only in terms of u of s. Therefore, from equation 3, taking this term a into x of s to the left hand side, we'll get s into x of s minus a into x of s is equal to b into u of s. Taking x of s common, will represent si minus a into x of s is equal to b into u of s. Here, this I represents an identity matrix which is having the same order as that of the matrix A. So this identity matrix is nothing but an n by n matrix with all its diagonal elements equal represented by unit value, that is 1, and remaining elements in the matrix are 0. So that it is easy for us to take the subtraction of the matrices Si and A. Therefore, x of s is equal to Si minus A, its inverse, into b into u of s. This Si minus A taken to the right hand side, which is represented in numerator, therefore it is its inverse, representing this x of s value as equation number 5. Then substituting this equation number 5 in equation number 4, we'll obtain y of s is equal to c into x of s. Therefore, that x of s value is substituted here. Si minus A inverse into B into u of s plus d into u of s as it is. Therefore, y of s is equal to bracket c into Si minus A inverse into B plus d, this bracket close, and multiplied by u of s. So taking this u of s to the left hand side, we'll get y of s divided by u of s is equal to c into Si minus A inverse into B plus d. So this is the Laplace transformation of output y divided by Laplace transformation of input u. So this represents a transfer function which is obtained from the matrix C, A, B and D with the relation as C into Si minus A inverse into B plus D. So this is the equation which is used directly to obtain the transfer function model from the given state space model. Let us have an example. This example is already discussed for a mechanical system. Convert the following state space model to transfer function model if k is equal to 3, b is equal to 1 and m is equal to 10. So this is the state space model of a given system with the first state variable as x, which is the displacement of the mass, second state variable as v, which is the velocity of the mass, f represents the forcing function, that is input of a system. Substituting all the values in the state space representation, we obtain the matrix A, B, C and D. This equation y of t does not contain any relation with force of the input signal, therefore D is equal to 0 and the matrix A, B, C are represented here. As we have the equation of transfer function y of s divided by u of s is equal to c into Si minus A inverse into B plus D, we'll substitute all the values of the matrices so that we'll obtain this equation. Now we'll simplify these matrices with the subtraction, addition, inverse and multiplication to obtain the transfer function. Therefore, first we'll simplify this for the inverse of matrix and then we'll go for the multiplication. Therefore, the inverse of matrix of this S minus 1, 3 by 10 and S plus 1 by 10. So it is nothing but the determinant of matrix which is represented here and the adjoint of the matrix. So this is adjoint of matrix divided by its determinant which is represented here. So everyone knows the procedure for calculating the inverse of matrix, as inverse of matrix is equal to adjoint of matrix divided by the determinant of matrix, and with that relation we obtain this inverse of the matrix, and this transfer function gets simplified with the multiplication of the matrices now. So this 0 into 1 is multiplied to this matrix, so it is will obtain only the second term, as first term is 0, therefore the only second row is present here. It is 3 by minus 3 by 10 and S term. Then I'll multiply this matrix with the last matrix, so I'll obtain this 3 by 10 into 0 and S divided by 10. Therefore this total term is multiplied by S by 10. So this is our transfer function which is obtained y of s divided by u of s, which is equal to 1 upon s into s plus 1 by 10 plus 3 by 10 into s by 10. After simplification we'll get s divided by s into 10s plus 1 plus 3. If you further simplify this, it will be s divided by 10s square plus s plus 3. So this is the transfer function which is obtained for the given mechanical system, which is represented in state space model. So this is how one can convert the given state model into its equivalent transfer function model. Thank you.